In this tutorial, we're using the normal probability distribution as an approximation to the binomial probability distribution. We're going to consider one type problem, that is, where we have the probability x is equal to a particular value. The objective is to demonstrate the use of the continuity correction factor by converting a binomial distribution probability to a normal distribution probability and solving problems of the type the probability x equals a particular value. You have already studied the binomial distribution and much of the normal distribution. Recall from the central limit theorem that as the sample size increases, the distribution of sampling means approaches a normal distribution. Thus, using information about the binomial and normal distributions, you will be able to substitute the normal distribution for the binomial distribution to solve probability problems of the type probability x equals a value. You have completed a study of the binomial distribution and a study of the normal distribution through the central limit theorem. You should be able to solve binomial and normal probability problems using the appropriate tables and selected technology. In preparation for an upcoming 15-game tournament, you have played the game 500 times. While playing the game, you recorded your number of wins. You won 300 games, so you won 60% of the games. That means the probability of you winning the game is 0.6. Before the tournament, you want to calculate some probabilities of the number of games that you may win. You recall from some information of your study of the binomial distribution and the normal distribution that you can be able to figure this out. Remember, there are 4 requirements necessary for a binomial distribution. Number 1, there must be 2 categories, such as success or failure, true or false, go, do not go. Number 2, there's a fixed number of trials, usually denoted by the letter N. And number 3, the 2 categories are independent. That is, the outcome from one does not affect the outcome from the other. And number 4, the probability of success, denoted by P, is constant throughout the problem. Also remember that the normal distribution may be used as an approximation to the binomial if we have 2 conditions met. N times P is greater than or equal to 5, and N times Q is greater than or equal to 5. Thus, we can use the normal as an approximation for the binomial probability distribution. While reviewing your statistics course notes, you find the continuity correction factor of 0.5 that must be used when you're approximating a binomial distribution using the normal distribution. This factor must be used because you're using a continuous distribution, the normal, to approximate a discrete distribution, the binomial. As part of your continued preparation for the tournament, you refresh your memory on the use of probability tables and the calculator functions relative to the binomial and normal distributions. After this refreshment, you decide to do some calculations of your possible winnings. The remainder of this tutorial consists of one exercise that will be worked using the normal distribution table and the calculator. Other tutorials will present additional problems using either the table or the calculator. For practice, it is recommended that you work the problems using all methods. Now, the problem we want to work is that if you won 60% of your games, what is the probability that you will win 10 games? That is, the probability that x is equal to 10. We could say the same thing by saying find the probability, that is binomial probability, for n equal 15, x equal 10, and p equal 0.6. You may use the calculator or the probability table. We see here that n times p is equal to 9, which is greater than or equal to 5, and n times q is equal to 6, which is greater than or equal to 5. Since both these are true, the normal approximation is appropriate for the binomial distribution. We have the probability that x equals 10. The normal distribution requires two values, a small one and a large one, to calculate the probability in an interval. Therefore, we use our continuity correction factor of 0.5. To include 10, we take the small value as 9.5 and the large value as 10.5. Therefore, we're looking for the probability that 9.5 is less than or equal to x less than or equal to 10.5. For the normal distribution, we need the mean and the standard deviation. As we see here using the formulas, the mean is 9. Standard deviation is the square root of 3.6. Using the mean and standard deviation as we just calculated, we can find the z-values that correspond to 9.5 and 10.5. Plug those into the formula and find the corresponding z-values. You find those z-values for 9.5 to be 0.26 and for 10.5 to be 0.79. Therefore, we have the probability that z is between those two values. Probability that z is less than or equal to the large one minus the probability it's less than or equal to the small one because of the way the table is set up to give us the probability to the left of the z-value. We take a look at that in the probability distribution table and we would see where these two values come from. In the normal distribution table, look on the left, you see your z-value is 0.2. On the top, you have 0.06. You come down and you see that value is 0.6026. Similarly, you have 0.7 on the left and 0.09 on the top, which gives us 0.7852. So the probability that z is less than or equal to 2.6 is 0.6026. Probability z is less than or equal to 0.79 is 0.7852. And we can use those in solving the problem. Therefore, the probability that 9.5 is less than or equal to x less than or equal to 10.5 is equal to 0.1826. This may not be quite as accurate as the calculator and computer because of round-off error for the z-values when we use the table. Now we'll use the calculator to solve the same problem. The binomial probability that x equals 10 converted to the normal probability that x is between 9.5 and 10.5. So we'll use the normal CDF function on the calculator because it calculates the probability we're between a small value and a large value. Of course, we also have to have the mean and standard deviation, which we calculated earlier. And we see here the output for that with an answer of approximately 0.18147. Let's summarize what we've studied in this tutorial. You reviewed the binomial and normal distributions as necessary. You studied two conditions, n times p is greater than or equal to 5 and n times q is greater than or equal to 5. Also, you studied the continuity correction factor of 0.5 and when to use it as you use the normal approximation for the binomial distribution. Once the tutorial pauses, you should take the self-assessment. After you complete the self-assessment, you may progress on to the next tutorial.